All right, if you would go and take out your textbooks, turn to page 176. As I mentioned in our last lesson, we're going to be skipping ahead over chapters 3, 4, and 5 to chapter 6. And we will come back to chapters 3, 4, and 5, though, in the not too distant future, like next semester sometime. All right, so let's go and review some things as we get to chapter 6, some things that we've already discussed. For instance, if we have an algebraic expression that has just a single term in it, we would refer to that single term expression as a...
algebraic.
Just a single term we call a monomial. A
you're
single term would be a monomial. Remember, a term consists of a numerical coefficient, right? Some literal coefficients, okay? Maybe some exponents in there on the variables and things like that. But altogether, just one term is called a monomial. What about two terms?
Binomial.
What about three terms?
Trinomial.
And in general, we can refer to these things as polynomials. But a reminder, something I said way back at the beginning of the year, one term I won't describe as a polynomial. Even though technically mathematicians say it is, logically, poly meaning many, one term is not many, so I don't consider a monomial to be a polynomial in the way I'm going to use the term. Okay, so polynomial will mean two or more for our purposes. Monomial will mean just one. Something that we had not talked about yet is something called the degree of a term. If you would in your notes, write that down, the degree of a term. Within a term, again, we said typically a term is consisted of numbers, maybe something like a -4, and letters, maybe something like an a squared, maybe a b, like a c cubed, something like that, right? This is all one term. The degree of the term is the sum of all exponents of variables. The sum of all exponents of variables. Now, technically, we understand that the 4 here, or the -4 rather, is to the first power, but that's not a variable. But looking at the variables, what are the 3 exponents on my variables here? Joshua?
The 3 exponents on the variables? 3, 2, and 1.
3, 2, and 1. We often forget about the 1, but don't forget a first power could be understood there. So if I were to add those exponents, class, what would I get? 6. So this is considered to be a 6th degree term. Easy enough? 6th degree term. It's just whatever the exponents add up to. What if I had a 5? Well, do I have any variables? No. Do I have any exponents?
Yeah. Well,
not on variables, right? So technically, what's the degree of this? 0. It's a 0 degree term. If I had something like this, what degree would this term be, class?
2.
A 2nd degree term, because I have exponents of 1 and 1, so a 2nd degree term when you add them all together. Does that make sense? Next thing for you to write down is the degree of a polynomial. The degree of a polynomial. The degree of the polynomial is simply the degree of the highest degree term. It's simply the degree of the highest degree term. So for instance, if I had a 5x and a -2y cubed plus a 7xy minus a 3y squared z. Well, what would be the degree of this polynomial? We look through the terms. What's the degree of this term, class? 1. This one?
3. 2. 3.
3.
Yeah, 3.
All right, so there's a tie, right? There's two terms that both have a 3rd degree, but what's the highest degree present? 3rd. So what's the degree of the polynomial? 3rd degree. It's a 3rd degree polynomial. Does that make sense? All right, so looking there at the degree of a polynomial, pretty straightforward. The next thing I want you to write down is this, descending order. And this is something I think we've already referenced this year, if I'm not mistaken. Does that sound familiar? Obviously, Lana and Josh, it should sound familiar from last year. Does descending order sound familiar to you guys at all? Okay, so not something I've talked about this year. Descending order refers to writing a polynomial so that the degree of the terms within the polynomial gets smaller. the degree of the terms within the polynomial gets smaller. So for instance, as we look at this polynomial here, let me do this here. Let me make this a z squared. So there's a clear winner here. So we have 1, 3, 2, and 4 for the degrees of the terms. Descending order is viewed one of two ways. First of all, where the degree of the terms gets smaller. So I would start by writing the negative 3 y squared z squared, because that's the highest degreed term. The next highest is the negative 2y cubed. So I would write that next. The next highest would be the positive 7xy, which is of the second degree. So I could write the positive 7xy next. And then my smallest degree term is the 5x. So I could write the positive 5x at the end. I've written it in descending order so that the degree of the terms gets smaller. Does that make sense? Descending, meaning going down, right? The degree is going down, it's getting smaller. There's another way the descending order may be used as well, though. And this is where the power of one variable gets smaller. Where the power of one variable gets smaller. That's another way you can use descending order. In this case, you would pick a variable. For instance, notice most of the terms have y's in them, correct? So the highest power of y, not the highest degree, but the highest power of y that we see, class, is?
4.
I see a y to the 4th? The highest power of y, not the degree of the term. The highest power of y I see is y cubed. Folks, break up. Okay. So then this is my highest power of y. So I can start by writing that first. Then after a y cubed, this term has a y squared in it. So I could write the negative 3y squared z squared. Then this term has a y to the first in it. So a positive 7xy. I'm going to go ahead and write the 1 so we can see it. And then finally the 5x doesn't even have a y. Although the degree is not getting smaller, the y is cubed, squared, first, gone. Or 0 power, if you will. Okay? So there's two ways in which descending order could be used. Normally, we actually mean this. Because oftentimes we'll have one consistent variable in our polynomials. But if there's kind of a variety of variables present, another way to set up descending order would be to make the degree of the terms get smaller. The advantage of setting up descending order is your highest degree term is at the beginning, so you can easily see what the degree of the polynomial is. It should be the very first term present. Questions on these terms, some new stuff for you here. Degree of a term, the sum of the exponents, degree of a polynomial, degree of whatever the highest degree term is, and then descending order, where either the degree gets smaller or one variable's power gets smaller. Questions on this? Look in your textbooks now at page 177. Look at example 6.1a. Notice they list out the degree of various terms. That first term has a first degree because it's just to the first power. Then we have fourth degree. It's to the fourth power. Then we have the seventh degree. There are two different variables present. We have to add both of their exponents together. The 5, of course, is to the 0 degree because if you were to say, well, it's just 5, right? 5 times what? 5 times nothing. What if you said, well, what about 5 times a? Well, there are 0 a's, right? Remember we said anything to the 0 power class equals 1 from past math classes, right? So this is 5 times 1, which is, of course, 5. Why? Because there are no a's. We have 0 of them. That's a 0 degree. But 0 doesn't even have a degree because if there were any variables, they would all be knocked out anyway. There's nothing there at all. You can't have a degree if there is nothing there. And 0 means nothingness. All right, questions on example 6.1a. Look at the next example, 6.1b. They have some different polynomials. They're looking for classifications. Well, obviously, since there's two terms class, we'd call that first polynomial a binomial. And what degree is it? Well, the highest degree term is only degree 1. So we would call it a first degree binomial. Look at the next one. We have how many terms?
3.
What's the degree of that polynomial? 2, because the highest degree term has a 2. So it's a second degree trinomial. Look at the next thing. Only one term, so of course that's a monomial. But what's the degree of the monomial? The 5th degree. Look at the next polynomial there. 4 terms. Okay, it doesn't have a special name. It's just polynomial. But what's the highest degree?
4.
4th degree. So it's a 4th degree polynomial. Notice, by the way, that the powers get smaller. 4, 2, 1, gone on the y. Notice on the 2 levels up, that trinomial, 2, 1, gone. Do you see that descending order? Also notice, if you would, the polynomials written. Do you see there's a little paragraph thingy? And there's a couple of polynomials right below those boxes. It's got a 5x to the 4th y squared, 3x squared y cubed. You see what I'm seeing? All right. So there's a couple different ways in which these terms could be written. If they wanted to descend the x, they would have a 5x to the 4th y squared, then a 3x squared y cubed, then a negative 7x, and then a 3y, where there is no x left. Or you could descend to the y, put the 3x squared y cubed first, then the 5x to the 4th y squared, then the 3y, then the negative 7x. In each case here, they descended them based on the power of the x or the power of the y, as opposed to simply the degree. But the first example also descends by degree. 6th degree, 5th degree, 1st degree, 1st degree. Makes sense with this descending order, where degrees get smaller or powers get smaller. Turn over in your books if you would to page 178. So flip the page, page 178. And let's do these together here. Number 1, what is that thing, class? It's a binomial. It's 1st degree, isn't it? Look at number 2, what's that?
Monomial.
Monomial. What degree is it?
1. 5.
5th degree. It's a 5th degree monomial. Look at number 3, what's that thing? Trinomial. What degree?
3.
No, 1.
1st degree, because no individual term has a degree over 1. All of them have a 1st degree. What about the next one? What's that thing?
Binomial.
Binomial, and it's also 1st degree. What about number 5? Monomial. What degree? 2nd. Look at number 6. What degree? 2nd, and it's a trinomial. 2nd degree trinomial. Good. On number 6? Yeah, x squared and y squared. So there's 2 terms that have a 2nd degree, 1 term that has a 1st degree. You go with the highest degree of the term. Within a single term, you have to add up all the exponents. But those are 3 different terms. So each term, you have 2nd degree, 1st degree, or 2nd degree. Does that make sense, the difference between that and, for instance, number 2? Number 2 isn't separate terms. That's all one big shebang. That's why you have to add them all together. Does that make sense now? All right, questions on that? All right, look down at number 7. I want to rewrite that so that the x descends. Okay, so we're ignoring the other variables. We're going with what I said is normally what we'll do, and that's power of a single variable. I want to rewrite it so the x gets smaller. How would I rewrite number 7, Lana?
8x cubed positive 5x squared negative x.
Good, the 8x cubed positive 5x squared negative x is correct. Number 8, how would I rewrite that, Joshua, so that the x gets smaller?
7x.
Well, careful, I don't have it. I don't have
Negative 7x.
Negative 7x squared, keep going.
Negative x positive 3.
There we go, negative 7x squared, negative x, positive 3. How about number 9, Dylan?
8x cubed positive 9x squared 2x.
Positive 2x.
Negative 3.
There we go. We have to put that positive because it's separating the terms from each other. Good. So 8x cubed, positive 9x squared, positive 2x, negative 3. How about number 10? Don't overthink this one too much here. Adam?
X to the 4th, negative 9.
I don't have a negative 9, nor do I have an x to the 4th.
I mean, not positive 9.
So from the top.
Negative x to the 4th, positive 9.
Good. Remember the sign is part of the term. So negative x to the 4th first, then the positive 9. Good. Number 10, Lana.
Wait.
Or number 11, excuse me. Just did number 10. Number 11, Lana.
Wait.
Exactly. Good. It's already in descending order.
That's what I thought. I was kidding.
Okay, I'm picking up. Number 12, Lana.
Negative 7x to the 7th, positive 5x to the 5th y, positive 3xy squared.
Good. Negative 7x to the 7th, then the positive 5x to the 5th y, and then the positive 3xy squared. Any questions on these? All right, mainly terminology there, not a whole lot of application, just some terminology, but the descending order is something that we'll revisit later. Next thing in your notes, this is going to sound really familiar, like we've done this before, because we have adding polynomials. Adding polynomials. Write this down, and again, this will sound familiar, but when you add polynomials, you can only add like terms together or combine like terms. So adding polynomials, you can only combine like terms. We've done this before, so this is really mostly by way of review. Look back in your textbooks, if you would, at page 177. Look at the example at the bottom of the page. They give you the polynomial 5x cubed positive 8x squared negative 3x positive 1. And they give you another polynomial of x cubed negative 4x negative 5. And the polynomials are being added together. What you're going to do is look for like terms. There's a couple ways you could do this. One method would be to rewrite the second polynomial beneath the first one so that like terms line up in nice, easy columns. You might remember doing this just a few weeks ago. Where I could put the positive x cubed below the 5x cubed, the negative 4x below the negative 3x, the negative 5 below the positive 1. And just add the columns together to get, class.
6x cubed positive 8x squared negative 7x negative 4.
There we go. Easy enough. The other way you could do it, instead of taking the time to write it out vertically like this, would simply be to mark. I've got an x cubed here. I've got an x cubed here. I've got an x squared here. I don't have any x squares there. I have an x here. I have an x here. I have a constant here. And I have a constant here. And you get your circles together to get
6x cubed.
6x cubed. I get my squiggles together. I don't have any other squiggles. I get the little whatever that is together to get.
Negative
7x.
And I get my arrows together to get. Same answer either way, right? It's just whatever you feel is easiest and best for you. How many remember doing this just a couple of weeks ago? All right, you don't remember? It's okay, as long as you understand this. Turn the page. Turn the page. My preference, to be honest with you, is this second method. I don't like taking the time to rewrite stuff. But notice on the second example, we've got some distribution that has to happen first. Well, we've seen this before as well. When we distribute the 5 atom, what do we get on that first example? On that second example, 6.1d?
5x squared 10x.
Positive 10x, don't forget the sign.
Negative 10.
5 times negative 1.
Oh, negative 5.
Good, and then distribute the 3 for us, Adam. 3 times x squared.
3x squared plus
And
3.
3 times 1.
Well, positive 3.
There we go. So we distribute first, and then again, it's just what's like terms. Here are some like terms, class, to get.
8x squared.
8x squared. Notice we went with the highest power first. Then we'll go with the 10x has no friends, so
positive 10.
yeah, it doesn't disappear just because it has no friends. And then the negative 5 and the positive 3.
Negative 2.
And we're done. Questions on this? At your seats, I want you to do numbers 13 to 19, the odd. You choose what method you like best. But 13, 15, 17, 19 says to add horizontally. You can do it every way you want to do. Good. Scott's finished. Lana laughs because she knows it's true. Dylan's finished. finish. Now Dylan's finished?
Oh no, it's just random.
Oh, okay.
Takes me my notes.
I'm writing a poem over there or something.
Oh,
Are you finished, Adam?
no, I accidentally did all of them instead of lines. So I was,
No wonder they
I
use
was
that
working
one.
on lines.
Adam, make sure you listen.
And Scott's on the camera saying, when are they gonna?
Scott's fast forwarding.
Probably.
Hitting the arrow key, skip ahead 5 seconds. Nope, they're not going over answers yet. Nope, not going over answers yet. Nope, not going over answers yet.
What if he actually does do that?
What?
So what if he actually does do that?
I probably would.
He probably
Same.
is.
Right in the 3 times mode.
Well, then, you know, I start trying to listen, you know, it's going to be what I say, so that's sad, you know?
I understand that.
I bet you do. Hey, I wonder if I put me on 3 times faster if I would sound like I was talking Japanese. All right, for sake of time, let's take a look at the answers here. And number 13. What'd you get for your answer, Joshua?
12x positive 5.
Right, 5x and 7x, 12x, 3 and 2 is 5. Number 15, what did you get, Adam?
9b squared plus 12, or positive, I think,
Look in your textbook at number 15.
15.
Look at it. 5b squared or
Oh.
2b squared? What does that give you?
7b?
7b squared. 8b and negative 6b. What does that give you?
That is my problem. I accidentally added,
What does it give you?
2b,
Good. And 3 and 9, what does that give you?
12.
We're done. That fast. Got it? Turn the page. Number 17. What do we get when we add, Lana?
5x squared positive x negative 6.
Yep. 5x squared, positive x, negative 6. Number 19, what do we get, Dylan?
9a squared positive 6a negative 6.
Good.
Wait,
Again, that was 9a squared, positive 6a, negative 6.
I crossed out the negative 3's.
It's not an equal sign.
Careful, yeah, they're not on opposite sides of an equal sign, so they don't cancel each other. Questions on that?
It's just on the last part of number 19, I multiplied them instead of adding.
Ah, yeah, we're just adding. All right, does that make sense now? All right, do 21, 23, 25, and if you get done early enough, 27. 21, 23, 25, and if you get done quick enough, before I call time, do 27. Feel free to mark these in your book. If you want to use that method, do the circles and the underlines and stuff right there in the book. If you want to copy them down vertically, obviously you can copy them onto your paper, but it's up to you. It really does. Number 25, you're going to have to do a little work on paper anyways. You do that distribution. So in that case, you might as well copy them vertically if you have to copy them at all. All right, if you must write them, write them vertically. Or chicken out of writing them because you're lazy. I can't do that on those.
Wasn't it just the odds?
21, 23, 25, and if you have time, 27. Finish with 27 as well.
Oh, wait.
Lana's finished. The 27 also. Adam finished.
I'm thinking I finished 27.
What about 21, 23, and 25?
Finished that.
Okay, good, good.
I'm just
Down
thinking.
On 27, can we multiply everything by the LCD and get rid of that fraction?
No.
No, it's not an equation. We actually have to distribute the fraction. We're stuck with it. Fortunately, it's not so bad distribution, as we'll see in a moment.
Well, I got 2 answers, so.
Scott's probably not even watching it right now, though.
It's not live.
Yeah, it is.
He's
right?
It's not, we're recording it and I'll upload later. So he'll watch it probably.
Can you watch it live?
No, we can't. YouTube shut down live streaming unless you have 1,000 subscribers, and I only have 25. So I've got 975 to go, right? And then I could do live
We
again.
should get the entire school to subscribe to you.
All right, let's take a look. That's only 100 something people. All right, number 21. I would start with the highest degree first. So I've got an 8q cubed and a negative 4q cubed. Class? All of you, stop what you're doing, put your pencil down, look at number 21, which is where I told you to look. I'm going to start with the highest power. 8q cubed and negative 4q cubed gives me?
4q cubed.
Thank you, Lana. Then I'm going to go to the squares. I've got a negative 3q squared and a negative q squared.
Negative 4q squared.
Negative 4q squared. Then I'm going to go to the plain old q's, but there aren't any. Then I'm going to go to the whole numbers. I got a 1, a 3, and a 1.
Positive 5.
Positive 5. I'm done.
Do you have to write them in descending order?
You don't have to. I like to. You don't, but yeah, your answer could be rearranged, but I like descending order because of where we're going. So that's the way I would approach it. But as long as your answer had these 3 terms in it, and that's it, then your answer would still be correct. Number 22, there's not really a clear descending order, but I do see AXs, which are second degree. Everything else is first degree. So I'm going to start with my AXs. And there's a lot of them, so I'm going to write them down. I've got a negative 2AX. I've got an 8AX. I've got a 2AX. Oh, what's going to happen with the negative and positive 2AXs, class?
Cancel.
So obviously that just gives me 8AX. Should we go with the A's or the X's next? A's? All right. So let's go with the A's. I've got an A. I've got a that's number 22. Odds.
We could have done that anyway.
Well, no, we'll save it for later. All right, number 23. Number 3, everything's third degree, right? So, I don't know. Let's just go with what's first. You got a 13a squared b, a negative 7a squared b, and that's it. So that gives me 6a squared b. Let's go with the next ab squares. I've got a negative 3ab squared, negative 4ab squared.
Negative 7ab squared.
I've got an 8ac squared and a 7ac squared.
Positive 15ac squared.
How many have that answer for number 23? Questions on that? Number 25, I distribute to initially get,
3x negative 15.
and I get,
Positive
5x negative 20.
and I'm just going to go and set it up like this. We add our x's,
8x
we add the constants,
negative 35.
and we're done. And here's the fun one. Brandon. You're not Brandon. Dylan, whatever your name is. You. When we distribute 2/3 times a 6y positive 12, remembering that the 6 is over 1, the 6 and 3 are going to cancel to give me
2.
and technically 1. Right, so it's going to end up being 2 times 2y is
4y.
but then we're also going to put the 12 over 1, and the 12 and 3 cancel to give me
4.
and 1. So I end up multiplying to get 2 times 4 is 8. There we go. We do the same thing with the next one, though I think the next one's even easier because you just take half. What's half of 4y, class?
2y.
2y. What's half of negative 8?
-4.
And we combine the 4y and 2y to get,
6y.
and we combine the 8 and the -4 to get
Positive.
positive 4.
Hey, I still had that and I did something.
Yeah, that's
wrong.
what I had the same answer too.
Did you get 12y over 3 plus 24y plus 24 thirds plus 4y over 2 minus 8 over 2?
No, I did 4y plus, I didn't distribute to the 12 or the
I got
negative
the-
8, but then I still got the same answer.
Ah, you just got lucky on that.
I
Okay.
did, what I did was, I took 2/3 of 6, which was
4.
4, and then add
2/3 of 12, which is 8.
8, and then
Because that's what it is, right? Of means multiply, right? So
Yeah.
we take 2/3 of that, half of that, and so forth.
and then
Right, questions on adding polynomials. Do we see how easy that is? Just get the like terms together.
Yes.
We good?
Yes.
All right, good. Turn the page. Subtracting polynomials.
I don't know.
Next thing you know, subtracting polynomials. This is also going to sound really familiar because you already know what I'm going to say. We never really subtract in algebra class. What do?
Add the
the
inverse.
So write that down. Add the inverse. Subtracting polynomials, add the inverse. Next section notes, subtracting polynomials, but under it just write, add the inverse. Though you might give yourself this reminder, you want to change all the signs after the minus. Change all the signs after the minus. Let's take a look at the first example problem here on that next page, page 180. And I'll show you what I would do because I'm lazy. I want to do as little work as possible and as quickly as possible while still being hopefully accurate. Here's the minus. I don't really subtract, class. I
Add the inverse.
So I'm going to change this to a positive or a plus. This currently has what sign in front of it?
Positive.
An understood positive. I'm going to put that as a negative, positive, positive. All the signs change. And I say negative 5x squared, negative 2x squared.
Negative 7x squared.
Thank you, Dylan. Negative 8x, positive 3x. Class.
Negative 5x.
3 and 12.
Positive 15.
Done.
Easy.
Same thing we were just doing. You just have to change to a plus and change all the signs. And that's it. Look at the next example. They give us an 8x squared, negative 7x, positive 1. I'm going to change the minus class to a
Positive.
plus, and then I'm going to change the negative 5x squared to a
Positive.
positive 5x squared, the negative 2x to a positive 2x, and then positive 3 to a,
Negative
and then we just add 8x squared, 5x squared,
13x
Squared.
negative 7x, positive 2x,
Negative 5x.
positive 1, negative 3.
Negative
We're done. Questions on this? Still seem easy?
Mhm.
Let me insult your intelligence for a moment. Look at top of page 181. We want to practice changing all the signs. Yes. So on number 1, I want you to go through and change all the signs. Let's do these out loud because we're too lazy to write it down. So number 1, what would I get if I changed all the signs? Adam?
Negative x to the fourth, negative 2x, positive 1.
Good. We just want to play that like 3 times speed. Okay. So how about number 2, Adam? Let's do it faster, please.
The negative 3x to the fourth, the negative x cubed, negative 2x.
Well, it wasn't quite 3 times speed, but whatever. How about number 3, Dylan?
Positive 3x squared, negative 8x, positive 3.
Good. How about number 4, Lana?
Negative x to the fourth, positive 3x squared, positive 8x, negative 4.
Good. Number 5, Joshua.
Negative 2x to the fourth, positive x cubed, positive 1.
Good. And number 6, Adam.
Negative 3x squared, positive 5x, negative 4.
That was much better. I didn't insult your intelligence, Scott, by saying them out loud, because if you couldn't hear them, surely you knew what you were doing. But hopefully you could hear them. Sometimes y'all's voices are awfully quiet. It's hard for the camera to pick you up. All right, so I want you now to do 7 through 13, the odd. Again, if it's after the minus sign, you change all the signs. And I do it right there in your book. I wouldn't even write them on paper because I'd be too lazy to write it on paper.
Lana's got. Lana's got him. Josh has got him.
Scott's got him.
Oh, Scott got him a long time ago.
Yeah.
He's probably eating his breakfast right now,
What?
munching on a granola bar.
Okay.
He doesn't get golden donut though.
Yeah.
Y'all got donuts for the last test, and I couldn't ship a donut to Scott, even though he made
He
it.
doesn't have to get to class on time.
Did you get to stare at his screen all day?
His class is his house.
Tough life, tough life. All right, we miss you, Scott. Is what they're trying to say. Just didn't come out that way. All right.
Right in the right corner.
All right, number 7. What'd you get for your answer, Joshua?
6b positive 1.
Good. 6b positive 1. Number 9, Lana.
9x negative 3.
Uh-oh. You keep they have a positive 5, and then what changes to a negative 2, keep the sign of the greater. 9x positive 3. I thought you said negative. 9x positive 3. Number 11 for redemption, Lana.
2x squared negative 2x positive 2.
There we go. 2x squared, negative 2x, positive 2, and Adam, number 13.
5x positive 3.
Uh-oh.
Mm.
All right, Adam, do I change anything in the first polynomial?
No.
No, because it's not after the minus sign. What do I get from the second polynomial when I change the signs?
Positive, negative 2x, negative 4.
Right. Okay, so what do I get when I combine a negative 3x and a negative 2x?
Negative 5x,
What do I get when I combine a negative 7 and a negative 4?
negative 11.
That's my answer. Negative 5x, negative 11 should have been our answer. Anyone go 4 for 4?
No, 3.
No.
All right, questions.
I got 3 out of 4.
Yeah, so
Dylan got them all.
The 4
Good.
for 4 meal.
All right, questions.
All right, go through and do 15 to 19 the odd now. 15 to 19 the odd. 15, 17, and 19. They're all odd. Doing a lot of odd problems. This is in honor of Scott.
Because he's an odd.
Because he's an odd problems king. We have a strange way of saying we miss you, don't we? Feed down, Lana. See, this way he gets to hear his classmates. On all the old videos he's been watching up till now, he had to listen to his brother.
Really?
Yeah, because Gavin was in the video class
And
last
Noah
year.
and Maddie.
And Bracken, yeah.
Oh, Bracken?
Bracken was in the video.
I forgot about him.
I picked on Bracken a lot. See, Scott, it wasn't just you. Bracken, too.
And now Dylan.
And now Dylan. Hi, Dylan.
Hola. You might also be able to hear the children across the hall.
I don't know. I'm curious. I'll have to go back and watch and see how well the camera picks you guys up.
Probably not that good.
Yes, sir.
I watched one of your videos and I could hear like the people singing from like a few years ago, like in the video. I could hear the people singing.
You, like, when you do videos, you go super fast.
Yes.
I had to pause it like 15 times.
That's what took me so long.
That's why it took forever on that.
Yeah.
You did it accurately though.
I think I told you to pause it multiple times, right?
Yeah, you kind of did.
Because basically every time you would work, it's okay, pause the video.
And since I work so long, it takes forever.
See, if Scott wanted to, he could still watch those videos you guys used last year. Or, the videos that the Algebra I students used last year, because they're still up there. But then he wouldn't get to hear your voices, and he would be sad.
And
He has friends.
why does he want to hear me?
Because
Because you're his little half niece. Oh yeah, we figured that out, Scott. You are Uncle Scotty to Lana now. Half Uncle Scotty. Yeah, it really is. But anyway, I don't know if that brightened your day or not. You and Lana are now related.
You guys want me to join yet?
I'm done.
I've been
I'm
done.
related to his sister. I don't know.
Life is always a race.
Oh my God.
Remember, in mathematics, there are two kinds of people: the
The
quick
and the dead.
I believe if I wanted to, if I didn't have my.
That's Scott's new slogan.
I can go back and do the evens if I wanted to. Still probably be done.
Go do it then.
No, because he tried to tell us to do that.
You're a good man, Dylan. I don't care what your brother says about you.
A lot.
Joshua. What? Cue the Jeopardy music.
My voice is too bad. I can't sing.
All right, let's go and take a look at these together. Number 15, what did you get for your answer, Adam?
Number 15. 12x squared plus positive 9x, positive 1, positive 3x cubed.
On number 15? Okay, Adam, let's try this here. Tell me how to write the problem. Well, do I do anything to the first polynomial, Adam?
No, sir.
No, I don't do anything. So I'm going to leave 9x cubed. I'm going to leave 8x squared. I'm going to leave negative 7x. I'm going to leave positive 4. What do I write for my second polynomial?
Negative 2x cubed, negative 5x squared, positive 2x, negative 1.
And I'm going to write them vertical like this. And I'm just going to add. I've got a positive 9x cubed and a negative 2x cubed gives
7x cubed,
8x squared and negative 5x squared.
3x squared,
Negative 7x, positive 2x.
negative 5x,
Well, I got that.
Positive 4, negative 1.
3.
We're done.
Well, I got that one wrong too, so.
Yeah.
Questions on number 15? Nope.
I don't
Number
know how I got that
17,
one.
Dylan.
2x to the fourth, negative 7x, positive 8x squared, negative 20.
Good. I would put the 8x squared before this negative 7x just so they're descending, but it doesn't really matter. 2x to the fourth, positive 8x squared, negative 7x, negative 20.
I just forgot
But
the
the order
negative
doesn't
20.
technically matter yet.
I did the same thing. I forgot to add the negative to the
What was
negative.
number 17 again?
2x to the fourth, negative 7x, positive 8x squared, negative 20.
Question?
Can you say that one more time?
No. Number 19, Joshua, what'd you get for your answer?
Positive 6 to the fourth.
6x to the fourth?
Yeah, it's 6x.
Mm-hmm.
Positive 3x cubed, negative 2x squared, positive x, negative 8.
Uh-oh.
Oh, wait,
Everything was good except your x. Look at your x terms. I've got a negative 7x, and then it says positive 8x, but that has to become a...
Negative 8x.
So I've got a negative 7x, negative 8x should have given us
Negative 15.
negative 15x. So the correct answer in descending order, which is what he had, 6x to the fourth, positive 3x cubed, negative 2x squared, negative 15x, negative 8.
I changed the sign.
Anyway,
I just forgot.
All right, questions 15, 17, 19.
I have a question.
We're going to be able to do the evens now successfully.
I will.
Yeah.
All right, there's your homework for this evening. Pages 178 to 179. Pages 178 to 179. I want you to do numbers 14 to 28, the even. And then on page 181, do numbers 8
through 20, the even. For both of these are in the practice sections, not the review sections. Okay, so not in the review, but in the practice where we were just working. Okay, so if it doesn't look familiar, you're in the wrong spot because it should look just like what you already did, just the ones we skipped.
What's today? 29.
It is Wednesday the 29th of September 2001. All right. And when the bell rings, she'll be
2001?
dismissed. 2021.
Oh,
I was just thinking everyone's paying
You
attention.
know, we felt like.
I know, you have time to get started on your homework. And if we'd been faster on the classwork, you'd have had even more time to get started on the homework. But we're going to end the video now so Scott can start on his homework too.
Bye, Unc.